A student is given two aqueous solutions, L and M, that both contain iron salts. The student does a series of tests on the solutions. Table 1 shows these tests and the observations. So we know that they're iron salts, and we know that we're getting some results. We know that Fe can only be Fe2 plus and Fe3 plus. What we have to remember is that iron 2 is green, and iron 3 is kind of an orangey brown colour. So if we're having a look down, immediately we can tell that L must have the iron 3 in because we've got lots of brown going on, and M must have the iron 2 in. When we're adding ammonia, ammonia is a base, so it deprotonates some of the... So in solution, remember that each of these things exists as the hexa-aqua ion. And when you add ammonia, it deprotonates until you get to that precipitate. And the same thing happens with iron 2, but there are only 2 of the waters deprotonated, it's 2 plus. When we add carbonate, 2 plus ions make the carbonates, but 3 plus ions act as acids, and they do the same precipitation reaction as above, and the effervescence, because they're acting as acids, they make carbon dioxide. When we're adding nitric acid and dividing it into 2 portions, nothing is happening, but then when we add barium chloride, we're getting a white precipitate of barium sulfate. That tells us that M has got sulfate ions in it as well, so it's iron sulfate. Here, when we add silver nitrate, we're getting a white precipitate, which tells us we've got chloride ions. So we've got chloride ions in here because we're getting AgCl as our white precipitate. It says identify all the precipitates and explain why effervescence is seen in the reactions of sodium carbonate with L but not with M, and give ionic equations for all reactions. So we just start at the top and we'll just do each test and all their equations and writing down the precipitates where, and then we can do the explaining the reaction with sodium carbonate when we get to it. So start with ammonia. Okay, so we need to explain the red-brown precipitate and give an equation. So we've decided that L is Fe brackets H2O6. It's the 3 plus 1 because it's all brown precipitates. We're going to add 3 ammonias because each ammonia is going to pull off a proton. So we're going to get H2O 3 times OH 3 times. That is our solid. And 3 ammonium ions. This is our brown precipitate. And then with M, it's a very similar reaction, but this time it's only 2 plus, so only 2 ammonias. Four waters remain, 2 are deprotonated, and we get 2 ammonium ions. And that is our green precipitate. So that's the first part with ammonia. And then we're going to start with sodium carbonate. We're only doing ionic equations, remember. So with L, we've got the Fe3 plus, and we've got the CO3 2 minus, doing ionic equations. Now, before I even draw the products, I can look at this and say, to balance the charges, I need to get 6 pluses and 6 minuses, because that's the first common multiple. And so I'm going to get 2. And when something is 3 plus, it's going to act as an acid and donate protons until it becomes neutral. There's my brown precipitate, same one as before. Plus 3 lots of CO2 gas, that's my effervescence, and 3 lots of H2O liquid, a bit of a squeeze in there. With M, which is FeH2O6 2 plus. It reacts with the carbonate ions in a different way. 2 plus ions are not as acidic as 3 plus, and so they make the carbonates, that's my green precipitate, a greeny grey precipitate often, and we just get 6 waters coming off. So if we go back and check, we've identified the precipitates in those first 4 reactions so far. We're going to explain why the effervescence is seen with L but not M. So effervescence is seen with Fe3 plus but not Fe2 plus, as Fe3 plus is more highly charged, so it's smaller and more highly charged. Same number of protons holding fewer electrons, smaller and more highly charged, so it has higher charge density. Fe3 plus is more able to polarize H2O ligands, weakening OH bonds in the water ligands, allowing H plus to be donated. H plus reacts with CO3 2 minus to form CO2 gas, which is the effervescence. Fe3 plus is more acidic than Fe2 plus. Our last little bit is about why we got a white precipitate for L with silver nitrate. And so that was a Cl minus plus an Ag plus gives AgCl solid. So this was a white precipitate. And M with, was it barium chloride that they used? Yeah. M with barium chloride. So we got Ba2 plus SO4 2 minus gives barium sulfate solid, and that was our white precipitate. So L is Fe, and it was 3 plus and Cl minus, so FeCl3, and M was Fe2 plus and SO4 2 minus, FeSO4.